Hi everyone, welcome to Wireless Sensor Network lecture series. Myself Sivalakshmi Pannaselvam, working as an assistant professor at RMK College of Engineering and Technology. Before moving into the subject, we will have a glimpse of our syllabus. Our syllabus is confined to 5 units. First unit will speak about the overview of wireless sensor networks. In second unit, we will discuss about the architecture of the WSN. In the third unit, we will be discussing about the protocols used in WSN. Fourth unit, we will speak about the infrastructure establishment required for WSN. And in the fifth unit, how the data management and security is ensured in WSN. So this is how our syllabus is confined. So in today's lecture, we are going to have an introduction on WSN. So before moving into the introduction, first we would like to know how far the communication has got evolved. So this is the question. So where actually it has started and to how far it has got evolved as of now. So as you all know, in the earlier days, the human beings tried for machine-to-machine communication. Later on, human tried to communicate with machine. And with the advancement in the technologies, human were able to speak with the other human. And we didn't stop with that. We also want to have the physical space around us to be connected with us. And we didn't stop with that also. We started monitoring ourselves. We didn't end up with this also. We started monitoring the things and controlling the things around us. That is what we call it as Internet of Things. Among the various communication, we would have a question. Is it really that necessary for a human to interact with the physical space or the physical environment around us? Yes, if some unintended events happen around us or any natural calamities approaches us, we could protect and prevent certain things if we have some sort of communication with them, so that through that communication we can continuously monitor the environment. Also, we can control the environment with through that communication. So to achieve that kind of communication, we need three main things. What are they now? Mainly, we need a sensor to sense the information what is happening around us. We need sensors. Those hardwares should be enabled with certain algorithms, set of protocols to be written inside. Okay. If we measure what is happening, the physical parameters around us, is that enough? No. It should be connected to the person who intends to know, who intends to monitor, who intends to control it. Suppose they are at the remote places now, they should be connected. So for that case, we should be having wireless communication. So wireless communication along with the sensor, is it enough now? No, because one sensor is not enough to find out the solution for, or won't be able to predict what is the event exactly happening, or we we can't also rely on one single sensor node's information. So we need to deploy a set of or the cluster of nodes around a particular environment where we are interested to monitor or to control. So those sensors has to be networked. So these three main factors are important to establish a communication between a human and a environment. That is your physical space. What are they now? Sensors, wireless medium, transmission medium, and in other ways I can put it in a proper sentence like sensors networked through a transmission medium. So On rearranging, we have something called wireless sensor networks. Finally, we end up with a domain called wireless sensor networks. So finally, I could say wireless sensor networks combine sensing, processing, and networking over miniaturized embedded devices called sensor nodes. There are few features that differentiates them from the conventional data networks. Mainly, they operate on batteries, and they could be distributed in large scales. They could operate in an ad hoc manner, that we call it as a infrastructure free manner. They are easy to deploy. The hardwares are available cheap. They can operate mainly at lower data rates. So these are the main key feature that differentiates WSN from conventional data networks. The key characteristics of WSN that differentiates from remaining networks are like they are able to reach the spaces where human beings can't reach. That is the first thing. So that is what it is being quoted here as they are able to collect information from the physical environment regardless of how easily accessible it is. They couple the end users directly to the sensor measurement by providing information that is precisely localized, and it also establishes a bidirectional link with the physical space so that they can remotely monitor, also control the environment if any action has to be taken. Coming to the application, here we have so many applications like industrial control, environmental monitoring and agriculture, structural health monitoring, marine monitoring, healthcare monitoring, and for smart homes. So as like we have listed here, there are many other applications which could not be confined into this one slide. So for having a better so as to have a better exposure, you can just browse and see what are the other applications also. So along with the applications, today I've brought two case studies. The first case study is about the case study on Golden Gate Bridge. The right side corner you could see the Golden Gate Bridge. Here the case study is about to monitor the health of the bridge. The members from the Stanford University during the year 2005, they performed this case study with the help of 64 wireless sensor nodes. Their main objective is to determine what is the health condition of this bridge, whether it is able to withstand the ambient and both the ambient and extreme conditions. So this was the case study actually speaking. What is my intention to bring this case study for today's video? Na? Here in the initial slides I have told you that the one main key feature of WSN is easy installation. Here the meaning of easy installation is you could see that this is a bridge which was built years back, right? Decades back. But with this latest technology WSN, we were able to deploy the 64 wireless sensors without disrupting what was existing. So they were able to deploy it, and with a structure of 46 hop network, they were able to monitor the health of this bridge, and they were able to come out with a report speaking about the health condition of this bridge. So for that reason, I brought this case study. If you want to view a detailed report on this, you can have or you can browse in your internet. So the next case study is about monitoring the humans ourselves. In the earlier case study, we tried monitoring the health of the building. Here we tried monitoring ourselves. So here the case study is nothing but monitoring the Parkinson's disease, which would usually we could see in elderly people, which was performed by MIT during the year 2009. The main objective of this case study is to replace human observer. We need not have a human continuously over all the 12 people's places. Here for this case study, they have taken 12 individuals participated. Okay, so as to monitor, say suppose if I want to monitor 12 elderly people with this kind of disease now, first of all we need to accommodate with us, and for to monitor these 12 people, continuous monitoring won't be possible. At every regular intervals of time we could be able to monitor, but that too with a different set of peoples. That is the case when human is involved in monitoring the other human, wherein with the help of this technology WSN, we were able to replace a human observer, and we were also able to help the physicians in fine-tuning the medication dosage for them. Since because it is continuously monitoring throughout the day, and they compiled this study for a minimum of 80 days. Okay, so imagine how far they would have gone into knowing each and every patient's history for those 80 days. So this would be really a boom for the physicians who are handling these kind of diseased people. So this is one such case study. Likewise, though we are speaking this about in 2024, there are as like many other studies going on. Just for an example, I brought two case studies. So imagine how important this WSN in our day-to-day life, because we live and dine with that, and it made our life in a better way. It has just uh, improved our lifestyles. It didn't stop with that alone. I've listed so many applications. I've brought two case studies also. It also, WSN also is a reason to make a revolution in IoT, because they were the enablers of the IoT. Why am I saying wireless sensor networks are the enablers of the IoT? Na? Because those are the people who introduced the cheap sensors, cost-effective bandwidth were introduced, and the cheap microcontroller processors were available. And instead of gateways, networking devices, we were able to make use of smartphones, our own smartphones as a gateways. And nowadays we are at times we are able to get fetch free Wi-Fi, and even if we want to own it now, we can own it with a very less cost. And we have a cloud to manage the data, and also we have a protocol, latest protocols IPv6 to network those sensors. So whatever the enhancements we have made, as I've told you, actually we tried communicating with the environment. We didn't stop with that. We tried to not only communicate, we monitored, we controlled, and we didn't stop with that. We ended up with we ourself monitoring and controlling our own bodies. And we didn't stop with that also. We started controlling the things around us. So that is what we call it as an Internet of Things. So with that technology itself, we were able to achieve this. Okay, so here we can have the history of your WSN. Just as a guest, I brought it. It'll be fun to watch. During the first phase of these end devices evolved, no, at those times these end devices were acting as a standalone computer. At times we used to call it as a working stations. Why do we call it as a working station now? They are not able to send and receive information on its own. We don't call it as a node, we call it as a workstation, because along with this standalone monitor, we had a CPU where all the applications and data would be stored to process those information. So here in the earlier first phase of our evolvement, we just had only one workstation, not only the one, individual workstations which would be operating individually. They are not interconnected. Later on, in the second stage of evolution, we were like we started connecting each other, because machine to machine we are able to communicate through the web. So the data were able to send and received send and receive through this second phase of evolution. Wherein the third phase of evolution, the web is being replaced with the cloud. Now we come across a word, a generic name called cloud for the web, because it not only sends and receives the information, it is able to store the information, and it also able to provide services through the application stored in the cloud. So here in the first phase, while it started evolving, we had a CPU in our own along with the workstation, where it stores the application and data, wherein nowadays we can store both the API and the data in a cloud, not in our own devices, end devices or the host devices. Okay. And latest what we started doing now with this facility, with this technology called cloud, okay, if we are able to store some sort of applications and data now, why can't we enable applications to control things and environment and much more? So we live in this era, that is the fourth phase of evoluted communication. So this is just a gist of again the communication, what how it got evolved. Okay. So finally, I could conclude saying that wireless sensor networks are a sophisticated technology comprising small autonomous devices known as sensor nodes, which has a pivotal numerous applications as I've listed earlier. And they also offer benefits like ease of deployment, scalability, and flexibility. However, they also face challenges including energy consumption, data security, and network reliability. So there are ongoing advancements in WSN technology which continue to enhance their efficiency and expand their potential uses. So with this, I'll conclude my introduction to WSN. In the future classes, we will get into the syllabus. Thank you.